we're aiming here to create both a technical and people hub of all the capability we need to model, simulate, design, and then operate and maintain the control systems for tritium facilities for all fusion devices in the future. So that's the real vision. But this is a sort of first step where we build our models that represent the technologies that we'll have in the heat facility. We validate those models using the heat facility. We train our operators using those validated models on our control system here. But then having got them validated and implemented, it's then possible to extrapolate from that to fusion power plants.
It was a great offering from UKAEA to help us keep our team together that's eventually going to deploy the big project. It's an excellent technological challenge as well, because what we're bringing together here are at least two separate technologies. So we're bringing together the equipment that we've supplied along with the equipment that the Atomic Energy Authority have supplied, interfacing them together to make them work as realistically as they possibly can. We then realised was that there's an awful lot of use cases for this piece of equipment that are coming more and more prevalent. Every time somebody said, hey, can it do this? The answer was, yeah, it can. And that got everybody's cogs working about what an important development this is.
So what we were aiming to deliver with this project was twofold. One was the requirement that we utilise the UK's wonderful industry capability, demonstrated so amply by Bilfinger UK, to try and make sure that we were placing more of our contracted work into industry. So the Fusion Industry Association reports for the last couple of years have increasingly highlighted that people need access to fusion data, modelling and simulation data, and facilities where they can access that and use it. So we're looking to the long term to create a hub where we have that capability, but also to showcase that capability to people who need it. And for me, it was really important to have a facility where we could bring people together and do their training and development, because the future skills for fusion is an absolutely key part of industry capability.
So welcome to the virtual control room facility. So as you can see, this is a real control room with a real control system, but the virtual part is the plant. So you can see over there, we've actually got a simulation running of a process plant running in software called Aviva Process Simulation. So our interest in a facility like this is it's a facility where we can literally do training on how to develop the capability we need to do our job. And it was really good to hit the ground running with a project that had such a clearly defined scope, clear requirements, so that then we could take that, put it out to tender, which was then won by Bilfinger. And then we hit the ground running with Bilfinger as well back in January when they started the contract. They were all systems go, you know, they had a design in mind, they were ready to go. And basically just by working quickly and efficiently with them, we're now at the stage where less than half a year later, they've delivered a fully finished control room facility for us.
So the simulator allows you to place the operator into various scenarios when the plant isn't in its normal running state. It then also allows the recording of the operator actions. So in the future, or at the end of the training, these actions can be replayed to the operator and you can show the operator how they've returned the plant to its safe, normal working state.
As modelers, we often like to go into the nitty-gritty of maths. We work a lot with theory, but in all of that, it's very easy to lose sight of the dynamics, the behavior of the system. With tritium systems, the facilities themselves are incredibly expensive. They take a long time to build, and there are many safety implications. So there is a very limited envelope of what you can test. Whereas with models and generally with maths and everything in silico, you don't have these constraints. But having said that, those learnings, the understanding that comes from this playtime, then informs the essential things like our safety systems. We're then able to generate the best response to a certain scenario where perhaps we'd have loss of containment or other serious incidents.
So one of the things I've been really lucky in this project is in having a really fantastic team of modelers, control systems people, and a great contractor who have worked together to execute the project really effectively. and also a really fantastic project manager who also came from industry, from Arcadis. I am not an expert in modelling, I'm not an expert in control systems, but I could see the opportunity to deliver something that's going to be really great for UKAEA in the future, and I really was happy to see those people come together and deliver it so well for us.